Hi, I'm Embry, Engineering Director with NGH.
And I'm Dan Ayres, Product Manager. We're here to talk about some upcoming changes in the industry. As the head of our engineering team, we thought it'd be a great opportunity to have Aaron fill you in on all the upcoming changes. If at any time you have questions, please feel free to send them in using the question button to the right of the screen. We'll answer those questions at the end of the presentation.
As you're probably aware, 2025 is a big year for the HVAC industry. New regulatory guidelines mean the refrigerants you've been using for the last few decades are no longer going to be shipped in new unitary equipment. So, we thought today would be a good opportunity to provide you some background on how we got here. We're going to describe the refrigerant NGH will be using, outline the impact it will have on your business, and provide some guidance for the landscape in 2025. In late 2020, the American Innovation and Manufacturing Act, or AIM Act, provided authority for the EPA to impose a rule banning refrigerants with a GWP over 700. This was done to curb the effect of global warming. But what is GWP, and how much is 700? GWP stands for Global Warming Potential, and it's how we measure a greenhouse gas's contribution to potential global warming. A greenhouse gas absorbs energy from the sun and traps it in the atmosphere. GWP is standardized on carbon dioxide, the gas we breathe out when we exhale. Carbon dioxide has a GWP of 1. R410A, which has been in wide use for over 20 years, has a GWP around 2,000, meaning it traps 2,000 times more energy in the atmosphere than carbon dioxide. Since that's well north of the 700 benchmark, we knew we had to make a change. There were a few different options, but it pretty much boiled down to two refrigerants, R32 and R454B. Our engineering team reviewed thermal properties, operating pressures, as well as GWP values, and we decided R454B was the way to go. One of the major reasons we settled on R454B was the low GWP number. R32 has a GWP of 675, just below the upcoming requirement. R454B has a GWP of around 450, which is well below the new metric for regulatory compliance. So, in addition to being a greener and more environmentally friendly refrigerant, we believe R454B will also last longer in the market as GWP limits may continue to lower. This means less turnover of our product line and fewer model numbers for our customers to remember. Another reason our team decided R454B was the right refrigerant was its similarity to R410A. Both refrigerants operate at similar pressures, which will make the transition easier for users. R454B also provides a slight increase in capacity over R410A, so the new refrigerant allows systems to have a 10 to 20% smaller refrigerant charge than an equivalent R410A system. All this proves R454B is the right solution for NGH. But there is one important aspect of this refrigerant I haven't talked about yet. You've probably heard the term A2L more and more these days, and for good reason. Both R32 and R454B are classified as an A2L refrigerant in ASHRAE 34, the standard that classifies refrigerants. This means they are considered mildly flammable. That is nothing to be afraid of, but it is something that everyone in the industry needs to understand and respect. So let's start at the beginning. What does A2L mean? ASHRAE 34 has classifications for both refrigerant toxicity and flammability. The first character indicates the gas's toxicity. The A in A2L means R454B is non-toxic, just like R410A. That's good news. The second digit indicates the flammability, and the 2 means R454B is flammable, unlike R410A, which is an A1. 2L means this refrigerant is lower in flammability than typical gases in the 2 category. Due to this mildly flammable designation, there are some things to consider during installation. The NGH engineering team has designed our new R454B equipment to help you make a successful installation while still maintaining our easy to install and easy to service feature set. Now that we know what the refrigerant is, you're probably wondering how it impacts an installation. Well, let's start with the obvious. What we want to avoid is leaking flammable gas into the indoor space. Should this happen, we need to make sure the air handling unit is able to detect the leak and then mitigate the hazard. Easier said than done. So let's dig a little deeper about what that means. First, we need to understand some principles of combustion. Combustion requires three things: an ignition source, oxygen, and fuel. In our case, R454B is the fuel. When a gas is the fuel, there is a minimum concentration required for combustion. We call this the lower flammability limit, or LFL. The LFL refers to the amount of fuel, R454B in this case, required to allow ignition. There is also an upper flammability limit, or UFL, where there's plenty of fuel, but not enough oxygen. Outside of that range, no ignition will occur. Think of it like this. We all know hydrogen to be flammable, but release a cubic meter of hydrogen in a large gymnasium, and you can introduce as many sparks as you like, nothing happens. This is because the gas concentration would be below the LFL of hydrogen. We use the same principle to mitigate the hazard in the event of a leak, diluting the refrigerant below the LFL. R454B equipped indoor systems will have a new kind of part, a refrigerant sensor. Should the system have a leak, the sensor detects the leak and takes action to reduce the concentration of refrigerant below the LFL. While the solution sounds simple, creating it was a bit more complicated. When we started developing our A2L systems, we identified a few different problems to solve. How do we detect a leak? Where do we put our leak sensor? And how do we take action to disperse the refrigerant? Let's start with the first one. Part of any servicer's job is detecting leaks. There are several ways to do so, but how do we detect a leak without human intervention? Visual and audio cues aren't practical, and we can't have the system spraying soapy water on itself. First, we identified all of the places that might leak. This is mostly at joints. Then, we used flow modeling software to run hundreds of possible leak scenarios, different locations, directions, and flow rates. We look at where the simulated refrigerant collects in the system. What you are seeing here is a simulated leak scenario in a package system. We use these simulations to pick a location inside the cabinet where a sensor can detect a leak before a flammable concentration occurs. We then verify this location in tests with real equipment and refrigerant. Once we know we have a leak, the system needs to do something about it. This is where the refrigerant detection system comes in. The refrigerant detection system, or RDS, includes the refrigerant sensor as well as signals to change the behavior of the system. Any product with an R454B evaporator will have both a leak sensor and an RDS. In most of our products, these will be integrated into a single part. You can think of the RDS as sitting in between the system and the thermostat. When a leak is detected, it starts controlling the system instead of the thermostat. The RDS will shut down both the compressor and any indoor heat source. It then runs the circulating blower at high speed for 5 minutes beyond however long it takes for the concentration of refrigerant to drop below detectable levels. The RDS also provides a 24-volt alarm output, which can be used as the details of the installation and local codes require. In most cases, the homeowner will experience a leak event as a loss of heat or cooling operation. By circulating the refrigerant throughout the conditioned space using the indoor blower, the RDS can reduce the concentration of refrigerant below the LFL. A2L refrigerants are nothing to be afraid of, but they do require some respect. It's critical that you carefully read the installation instructions and labels on any A2L equipment you're installing or servicing. You must also become familiar with the code requirements in your location. We have done a lot of work to make our products comply with the requirements for use of A2L refrigerants. And the final step in that process is the product being properly installed. HVAC professionals have been safely installing natural gas systems for decades, and we can do this too. As long as you follow the installation instructions of the equipment and follow all local code requirements, your new A2L installation will provide a safe solution for your customers while providing smooth, reliable comfort for years to come. All right, Dan and I are now ready to answer some questions.
Thanks, Aaron. So we've already had some great questions coming in, so we'll go ahead and start right now. Just a bit of housekeeping is if you don't see the question bar, try exiting out of full screen, maybe hitting the X or the escape key. So the first question coming in, you said that 410 has similar properties to R454. Can I charge a 410 system with R454?
No, you cannot. So yes, the properties are similar, but they're not the same. So first of all, the compressors are specific to a certain refrigerant. So you would not get the same performance if you switched gases as are the expansion devices. But more important than that, an R410A system is not designed to mitigate leaks the way an R454B A2L system is, right? So that has to be in place. You're not allowed to change the flammability classification of a system in the field. And just to maybe head off a follow-up question, you cannot simply just add an A2L leak sensor to an existing R410A evaporator. And that's because the sensitivity and the position of that leak sensor have been very carefully selected by the manufacturer. And just adding it anywhere is not the same as adding it in that very specific location.
Yeah.
You cannot replace an R410A system, or pardon me, you cannot replace R410A with R454B in the field.
Yeah, there's a lot more complex than that, which makes sense. Another one comes in. So if the new refrigerant is flammable, how does spreading the refrigerant through the house with an indoor blower actually stop a leak when you want to try and trap all that refrigerant somewhere?
Yeah, that's a really good question. So remember what we just talked about with the three pieces of combustion, right? So to have combustion, you need a fuel, you need an oxidizer, and you need an ignition source. And we have that idea of concentration that becomes flammable. So below that LFL, lower flammability limit, we can't ignite that mixture. So what we're doing when we activate the blower in the system is we're spreading all of that leaked refrigerant that might just be enclosed in our equipment throughout the entire space, all the ductwork and all the structure, right? And what we're doing is keeping the total concentration of refrigerant below that flammable concentration. That's how we're making that safe. Now, that does bring up a good point. There is, per the safety standards, a maximum allowable charge for a given amount of space that you're servicing. And so to maybe make kind of a silly example to illustrate this, imagine you had a 5-ton heat pump that was servicing only a very tiny room, like a closet or something like that, right?
A restroom or something.
Right.
Sure.
You could imagine that if that system leaked its refrigerant only into that space, it might still get above that lower flammability limit. And so that's why there's a maximum on the amount of refrigerant for a given space. Now, in practice, I think you'll see that this is not generally going to be a problem. Like to put some numbers to it, for one of our systems, say a 5-ton heat pump with 75 foot of line set for us might be around 10 pounds of charge. Okay. And if you do the math on that in the standard, that would equate to a minimum area, assuming a 7-ish foot ceiling, of about 150 square feet. So quite small.
Yeah.
So I think in almost all cases, you're going to be able to apply a 454B system in the same applications you'd be able to apply a 410A system. You're not going to run into that, space requirement based on the refrigerant charge because of the relatively low charge weight.
That makes sense. That's a good question. So we got a lot coming in. Thank you everybody for your questions. If we can't get to them all, keep sending them in. We'll hopefully respond on the next Lunch and Learn and maybe reach out as needed. Here's one that I actually hadn't thought about yet. What if you have more than one system in the house, maybe upstairs, downstairs, and one services that you have to do a replacement? Do you have to change both systems? Or how does that work?
Well, it's a great question. So no, you don't need to change both systems necessarily. You can mix refrigerants like that. And this is probably a follow-on question to this charge weight, maximum idea. There's two ways that could work. You could have twinned systems where I have two physical separate systems supporting the same space. And if that's the case, you make that minimum area calculation based on one of the systems, right? Not both. The assumption is that one of them might leak, right? In the other case, where you have maybe an upstairs downstairs system, you would make that calculation based on the area of the part of the structure that they service. So you would take a look at the charge in the system that services downstairs and the area of downstairs. And then separately, you would look at the charge of the area that services upstairs or the system and the area of upstairs. And so this is really maybe the one case where you could get into something here with this max charge weight. And that would be probably an unusual application where you've got a relatively large system or a relatively large or long line set that's servicing a very small area. So like a bonus room or an enclosed porch or something like that, need to pay attention to that. Our instructions will tell you very clearly how to do this comparison of charge weight and area. So we'll do that for you. There'll be tables in the instructions, and we'll give more details on those as we go forward. But it also does bring up a good point that it is important. There will be a maximum allowable charge value on the equipment, and you should not exceed that, right? Based on, and we'll have, again, guidelines for line set length, charge nets, and things like that.
Yeah, and I think that's probably a good time to at least reinforce that the install instructions are really going to be the source of truth for a lot of this, right?
Yeah, that's a good caveat in general. And really, I should say that, end of the day, we're going to try to provide you the best information we can here right now. But at the end of the day, it is really the contents of our installation instructions or anybody's installation instructions, any OEMs, as well as the local codes where you live. So a lot of this information that I have is based on the national codes like ASHRAE 15.2 and the Safety Standard Rebuild 2. But there could be variations in your local code that go beyond those requirements or supersede them. And frankly, a lot of them aren't done yet. There are some states where we're not exactly sure what all those codes are going to look like. And actually, AHRI has a really good tool, and there is a link to it. If you're on the video player, there should be a little link icon, I think, to the left of the video. There's a link in there to AHRI's code map where you can click on your state and you can see the status of your local codes and if they've been updated or not. So that's a pretty good tool. Yeah,
that would be very helpful because the AHJs for each different state and county, can enforce the local codes that we might not be up to date with. We make equipment for the entire country and even into Canada. So, that's great stuff. Another question we have, kind of dovetails into that one nicely about existing line sets. Do you have to replace a line set, moving from 410 going into an A2L?
No, you do not have to replace the line set, but there are some things to understand. ASHRAE 15.2 is going to require that line set be pressure tested, both at a high pressure and at a vacuum test for leaks. And we'll have details in our instructions about how that's done. They're also going to require that the line set be exposed for inspection. And there's really two things that they're looking for there. One is that those joints are all appropriate, and also that there are nail shields installed anywhere where the line set is concealed behind a wall where it might be pierced by somebody hanging a picture or something like that, right?
Sure.
So that could be hard to do. There is a provision that if you can establish via building inspection that the nail sheets are in place, that's permissible. But there's going to be a requirement that we're able to pressure test that line set if it's reused and make sure that we have those nail shields in place.
Great. Yeah, good stuff. That's all going to really impact an installation and especially on that replacement deal. So great question. I hadn't actually thought about that yet. So here's another one. This kind of more almost ties into components to an extent. Asking about mechanical joints. So we know that's big in manufactured housing. Can we still use those, or do we have to braze everything?
Yeah, so we feel like brazed joints are best when it comes to leak performance, but you can use a mechanical joint. The requirement is that the joint method be UL 207 listed. So you'll have to talk to your joint method provider, whatever that is, to make sure they have that. And then it has to be actually installed per their instructions. But as long as you do those things, you can still use a mechanical joining method. This also gets into if you have, for some reason, an existing line set that has an existing mechanical joint that you want to reuse, it could be very difficult to ensure that that joint was done to those standards, right? So that might be a case where you need to replace that joint potentially.
Yeah, that makes sense. Well, here's one that actually we've gotten this one quite a bit as we've talked to our customers in preparation for the A2L switch. Talking about matching our evaporator with another manufacturer's furnace. Does that go away? Does it have to be three-piece match now? Can you maybe elaborate on that?
Yeah. So you can use our evaporator with someone else's furnace in an A2L application, or even our own furnace that was built, 5 years ago or something before this was on people's radar. And the way that's going to look is, once again, you need to install it per our instructions and wired per our instructions. And what that'll look like is our RDS that we talked about will send an activation signal to that furnace, whoever it is, via a high-speed cooling call, Y cooling call. And that's how it will activate mitigation performance for their blower.
RDS, refrigerant detection system.
Refrigerant detection system.
Try to stay up to snuff on all the new nomenclature. Great, and it's running on the high speed blower because you want to dissipate that as quick as you can and spread it throughout the house.
We want to mitigate that as quickly as possible.
So it's not a W call where it might just be a circulation.
Yeah, or a G, right? Yeah.
Right. Well, here's about the other way around. Can you put somebody else's coil on our furnace?
Yeah, really good question. So nothing about our furnace is going to preclude you from doing that. So I'd say the answer to that is probably. And the reason I say that is the manufacturer of the indoor coil is responsible for the leak mitigation methodology in an A2L system. So I'm going to assume that other manufacturers are going to create methodologies to use other people's furnaces, but obviously I don't know that for certain.
Sure.
But more than likely they'll have a way to do that. And really, I'm going to say this a lot. It really comes down to carefully reading that indoor coil manufacturer's instructions, understanding how their RDS works, and then understanding how the blower activation works in our furnace or anybody else's, because that's the two things that have to get married in that situation. Is we need a signal from the RDS going out to the furnace to activate the blower. And actually, Dan, I just remembered something relevant to one of our previous questions that I'd like to add. When we talked about maximum charge weights and multiple systems, maybe upstairs, downstairs.
Sure.
There's another thing to be very aware of in a zoning system. So if I have a zoning system with dampers on my equipment, part of the requirement of the safety standard is that if there is a mitigation action going on for a leak, all those zoning dampers need to open up. And the reason for that is because, remember, we're trying to distribute this refrigerant through the space
as quickly as possible.
Yeah, and if the zone was configured such that it's dumping all the air into a bedroom or something, it's as if we're only servicing that part of the home, right?
Yeah.
So we need to open those up. So our RDS will have a kind of utility output that it will send out 24 volts in the event of a leak or of a fault on the sensor. Mm-hmm. And you can use that then to do whatever you need to do to your zoning system to make it open up, right?
Yeah.
So you might cut its power if it's a spring open, right? Or something like that. But that is an important detail with zoning systems we haven't had before.
Yeah, and that's just, understanding how the system works, being familiar with your local AHJ.
Yep.
And just, doing all the proper things to make sure you're doing a safe install.
Yep.
Yeah, great question, great point. Here's one about storage in the warehouse. Do you have to get new approvals to store R454B in your warehouse?
Well, so potentially. So R454B is a flammable gas. There are maximum allowable quantities, based on National Fire Protection Agency rules and things like that. How big that quantity is really a function of the occupancy class of the space we're talking about and how big it is and what kind of sprinkler system it has, if any. Mm-hmm. So, really your best next step there is to talk to your local inspector and or your insurance company to make sure you're covered for storing equipment and the actual cylinders potentially.
Yeah, that's a great point.
Yep.
I guess probably the same would be true for trucks and transportation.
Yeah, so for transportation, the U.S. Department of Transportation has said that for individual pieces of equipment with onboard charges less than 26 pounds, there's no special permitting required. So under 26 pounds means no problem for any residential equipment, ours at least. And so other than that, though, transporting a cylinder of our 454B, contractors are already transporting flammable gas cylinders for their torches.
Sure.
And the same kind of precautions would apply for
Yeah.
a cylinder of our 454B.
And oxygen, acetylene, those are A3s, I'd imagine.
Well, no, not refrigerants, but
yeah,
they're
sure.
that kind of level of flammability. Yeah.
Thank you. Great. Appreciate the hope. I'm getting some questions coming in about different tools. Gauges, do we have to replace all of our gauges? Can we reuse some of that stuff? I guess it kind of depends on which gauge you have, but any good guidance we can provide there?
Yeah, really good question. So anything that is electromechanical that's interacting with the refrigerant, like a vacuum pump, you're going to want to make sure that it is A2L rated. And to do that, you're really contacting your manufacturer of that device and making sure that they're saying it's okay for that. For more kind of passive things like hoses and gauges, those things won't necessarily carry like an A2L cert, but we don't want to cross-contaminate refrigerants. So you're probably going to want to have a separate set of hoses and gauges for 410A and for 454B and maybe 32 potentially if you're into that as well. So
Yeah, that makes sense.
Also, you're going to want to make sure that if you have a leak sensor, a handheld type leak sensor, that it's good for 454B.
Yeah, like a sniffer. I didn't even think about that. Yeah, that's a good point. How about actually setting up the system? When you go to charge it, is this charge completely different? Are we still using superheat subcool?
Yeah, the charging process is going to basically be the same. You're going to charge via either superheat or subcool based on what kind of expansion device and whatever our instructions say. It is a 400 series refrigerant, so it's multi-species, meaning you're going to want to charge it in a liquid state, just like 410A. And you're going to see, charge weights for a given level of a given capacity of system are going to be a little bit smaller than they were with 410A, but the actual process of charging and the instructions to do so are going to be very similar to what we have today.
Okay, great. Trying to keep up. There's a lot coming in. So talking about the actual system, it seems like the sensor's doing a lot of the heavy lifting here. And is that really the only thing that's important in an A2L safety system? Are there other things we have to think about beyond just the sensor?
Yeah, it's a really good question. So yes, there are. So while the sensor and the RDS are kind of the centerpiece of the mitigation system, you will see other features in the equipment that are related to it. So on our equipment, you'll find some small sheet metal flanges and some other kind of cabinet details that are related to containing a leak, that are related to directing a leak towards our sensor so that we can detect it more quickly. You may see some cases where a compartment that is fairly closed today has some ventilation holes added. And you might think, well, why? That's going to let refrigerant in. But in fact, it's very difficult to keep refrigerant out of any given volume. And should we activate our mitigation system, we want that compartment to be flushed through by the blower and pull that refrigerant out. So you'll see some things like that.
Yeah.
Go ahead.
Well, that makes sense. I know there might be some questions coming in.
And actually, one more thing on that. Sorry.
Hope so.
We're also, in certain cases, going to replace components with special A2L versions that are non-ignition sources. So things like a contactor, we'll have a special version of a contactor that has some protection around that. And what that means is that when you're doing replacements, service, you might need to replace a part. It's very important to look at our replacement part list and understand what kind of contactor or relay might be required for that application, because a generic replacement may not be suitable for that.
Yeah, we've had some questions coming in for very similar to that. Actually, there's one right here about contactors. Another one about fan motors. Are the fan motors sparkless? Is there any concern there?
Yeah, so it has to do with the activation energy and how many VA the motors are consuming. But yeah, right now we're not seeing any changes to our fan motors compared to before. Yeah.
Great. Here's one, and this is a little bit more of potentially a rumor, and hopefully we're good. It says, I've heard if the system's under 4 pounds, you don't need to do anything different. Comment, is there no RDS? Maybe address some of the rumors that are circulating.
Yeah. So there is a minimum charge weight, or I should say a maximum charge weight, below which you do not have to have this sensor and RDS system. Mm-hmm. So there potentially could be some systems that are below that level and therefore don't have this mitigation system. But a lot of the other precautions around how you handle them and charge them and are still going to apply, right? So we're still going to want to use appropriate tools on those systems, and we're still going to. There is also, I should say, one thing I want everybody to understand is that if you're doing industry best practices now when it comes to handling equipment, you are 95% of the way there to being ready for this, right? Mm-hmm. Because the OEMs have dealt with a lot of the other details around the RDS and whatnot. So, when it comes to evacuating a system, right? ASHRAE 15.2 would tell you that the best practice is to pull that system down, sweep it with nitrogen, and then pull it down again. And that is actually still a recommended, not a required thing under 15.2. Again, your local codes might be different. But one thing that is required is that if you're going to open a system using a torch after you've pulled it down, is that you run a inert gas behind that while you're doing it, nitrogen being the most likely one. Which
Even
again,
I know nitrogen. Yes.
Which again, a really good practice. You probably do that anyway, but that's very important. You can have refrigerant that's been trapped in the system, might be infused in the oil. That after you get your hoses disconnected and you're going to open that system, you don't want refrigerant right behind there while you're making that braze,
sure.
Right?
Yeah, with an open flame, of course.
Yep.
So, sounds like if you had a coil that used up to 50% less refrigerant, that would be an advantage in the A2L world,
yes,
right?
It might be an advantage.
Well,
that's
we
right.
should look into that. I have some questions here about the actual refrigerant itself, what it's made of, what kind of oil it uses. Can you comment on that at all?
Yeah, so same kind of oils as we're using today with R410A. It is a blended mixture of R32 and R1234YF are the two components in it.
Okay.
And so in that regard, very minimal glide. It's going to be similar to 410A in that kind of way.
Okay, all right. Here is one about some training curriculum for contractors. So, this is the first thing that we've put, at least in this form. We have some training materials we put out asking about, what else are we going to have for contractors. So this is the first of 3 lunch and learns for the spring. So we'll be doing another one next month that's going to be a little bit more on the product side, not ready to get specific with that yet. But some of the changes you can expect to see, sheet metal, that sort of thing. And then we'll have another one with maybe a little more in-depth with some of the componentry. And then we'll hit a whole wave of training materials, the FAQ sheets. We'll take some of the questions come in here. We're not going to have time to answer, address those. And then in the fall, we're going to do another 3 rounds of training. So we're going to try and hit you guys with as much information as possible. Everything we can do to help you be prepared to answer your customers' questions. If your homeowners have concerns about adding a new A2L refrigerant into their system, we're going to arm you with as much stuff as we can to help you answer those questions, assuage their concerns, get the sale, and install a good system for them. So.
Yeah, Dan, if you don't mind, I see a couple questions here. Maybe I'll
you're going to default to me?
I'll catch real quick if that's all right.
Oh, goodness.
So there's a question here about how to be packaged. So A2L refrigerants will have a red stripe on the cylinder. Okay. Right, that's one way to identify them. And then I think you'll find that mostly they have left-hand threads. So actually, when we talked earlier about equipment that you might need, our observation has been we've received some that didn't have left-hand threads, but I think you'll find they have left-hand threads, which means you'll probably need adapters for your hoses potentially to connect to that tank, right? So.
Great call. I have one here that actually is good. And I don't know if we've discussed this before, but I'm sure you're so smart you have an answer, you and your team. Are there any concerns for blower motor failure in RDS?
Yeah. So if you have a blower motor failure, you're going to essentially that RDS is going to be out of commission right now. That means you're going to get a service call anyway. Sure. Right. So we'll want to make sure that we have an operational blower on our system by the time we leave that service call. Yeah.
And odds of them going out at the same time, weird stuff can happen, but a leak and a blower motor failure I don't know what really we can do as a manufacturer on that. Here's one good kind of about a system matchup. So if I install a current furnace, then install an A2L AC next year, will there be a retro kit available for the furnace to activate the blower in case of a leak event?
Yeah, so you won't have to have anything like that. When you buy an A2L evaporator from us, it'll come with everything you need to make that furnace become the mitigation blower in the event of a leak.
Yeah.
So yeah, you won't have to.
Yeah, if you're doing an A2L system next year, that's going to have the outdoor, the indoor unit,
Yep.
and that's going to have the RDS on it, so it'll wire directly into the blower.
Yeah, and maybe to be a little more clear, our residential furnaces are not changing, next year, right? So they're going to be the same models we have today, at least with regard to A2L type stuff. And also our RDS, there were some questions I saw too about kind of what's this thing look like. Our sensor and RDS are all packaged into one box, if you will, and do not modify our controls in any way. So same control boards you're used to working with now, we're talking to our systems from the RDS via thermostat inputs. So when I like to think about it as the RDS exists between the thermostat and the equipment, and if we have a leak, the RDS basically takes the thermostat out of the equation and says, I'm going to control things now.
Sure.
It's going to do that mitigation activity. And just as a reminder, we said this earlier, but if you have a mitigation event, it's going to run the blower until the signal goes away. And so it stops seeing the leak. And then it's going to wait 5 more minutes, continue blowing, and then it's going to go back to normal operation. So, a question you might have is, well, what happens? I've got a heat application, I've got a furnace. I don't actually need my air conditioner right now, right? If you had a leak in that situation, it would mitigate that leak until the system stopped leaking, most likely because it's out of refrigerant, and then it would go back to being a furnace after that, and it would allow normal operation once it no longer sees that refrigerant there. So then you'd have a chance to come and do your service call and get that fixed.
So in that scenario, you might not even know that you had a leak unless you were paying attention to your alarm systems that come with the RDS. You might not know you have a leak until the spring when you kick your cooling system on and you realize it's not doing its job. Well, you had a leak 2 months ago, but you've been running your heat this entire time.
Yeah, which is how it is today, right? So that might show up as just lack of cooling or low pressure switch trip or something like that. But yeah, it will allow it to be a heating application after it's dealt with that refrigerant loss.
All right. Here's another one just about kind of labeling on equipment. Are we going to have A2L stickers on the equipment? How do we call that out?
Yeah. So we'll provide imagery for all of that as we go forward. But yeah, there will be a flammability notification on the equipment itself near the service valves, indoor and outdoor. And of course, our literature will have that as well.
I had another one here. They're moving pretty quick, but asking about 410, how do you top off a 410 system? And feel free to add some color here, but it's important to remember 410 is not going away as a refrigerant.
Right.
You are still going to be able to purchase that and carry it because you have to service your customers, and not every system needs a full replacement. But what you won't be able to do is buy new equipment with 410 outside of a year. We do have the 1 year sell-through, of course, but as a manufacturer, we can't make it next year. So just because the new equipment in the market is going to be an A2L system doesn't mean that R410A is going to completely disappear, much like R22 is still available commercially.
Yeah, so if you have an R410A system out there, you can still repair it. You can still add R410A to it as a service activity. But yeah, if you're going to install a new system after January 1, I should say, we didn't say this, probably should. It is a manufacturer date based requirement. So when we just did the recent SEER 2 changes, there were some places where it was an install date requirement, right? That's not the case here. So any piece of R410A equipment built prior to January 1, 2025 can still be installed after that date. And right now, there's a little bit of discussion about this in the industry, but for package units, it's pretty firm that that's going to be a 3-year sell-through, right? And then for split systems, it's going to be at least a 1 year sell-through is what we're looking at. So anything built this year or even last year, you could still sell through 2025, or install, I should say, through 2025 before you run into having to use a 454B in a new install.
And I'm sure our distributors are happy to hear that, so they don't have to worry about bleeding out your inventory. You'd be stuck with, the common term we use is a boat anchor the next year because
Yeah.
you can't install it. After
Yeah,
that,
there'll be
so
some on-ramp, off-ramp for that equipment. Yeah.
That's helpful. I
Yeah.
like one item.
Yeah,
here.
sir. There's a question about the warranty process for RDS systems or sensors. So, not really my area, but I'll try to give an answer there. I think it would be the same as any other component, right?
Yeah.
So if you had a failure there, the RDS and the sensor are self-testing. So they will, if they have some kind of fault condition or something like that, they'll indicate that by going into a mitigation state. And should you have that, it's going to be like any other component in the system with regard to warranty. We're looking at a 15-year plus lifespan for the device. So it's not something you have to replace every year, every 5 years, or anything like that.
Here's a softball question. Do the systems come in heat pumps?
They do. Yes. Yeah. So, and really our lineup going forward is going to look very similar to our lineup today. Mm-hmm. So if you're used to getting something from us in 410A, very likely you'll have that same thing in 454B, and very likely it'll be similar. So I believe the number is for outdoor condensers, 85% of them are going to be exactly the same dimensions that they are today. There are a couple where we were able to shrink the footprint a little bit. Well, there's two sizes, so from large to small. And then there's a few cases where the height may change by our 4-inch increment.
For the better. So if you're stocking a warehouse or something, you're not going to see boxes get bigger. You're going to most likely see not very much change at all. But if you do, it's going to be smaller, which we agree is always a positive.
Yep.
What I always tell you guys, if you can find a way to make an AC the size of a shoebox, we could probably retire tomorrow.
Yep, we could. Yeah,
unfortunately, can't do that. Here's just some question about TXVs. Are they going to be rated? Any change to where they're going to be located?
I'm sorry.
TXVs.
Yes. So the
A2L rated or whatnot.
Yeah, they'll definitely be different because a TXV, works. It has that charge bulb that's sensing the temperature in the system, and the gas that's in that charge bulb is specific to the refrigerant that it's metering for. So that charge is going to change when you're using R454B. So you certainly have to use an R454B specific TXV in an R454B system. If you tried to use a 410A one, you wouldn't get the right behavior when it comes to the valve opening and closing.
And that's the same as you'd see now. If you try to do an R22 TXV,
Exactly.
It wouldn't work with 410 just because of the thermodynamic properties.
32,
wouldn't work.
same thing. Yep.
Yeah, that makes sense. So there's a question here about sensors in the warehouse to detect leaks.
Oh, like for storage?
Yeah.
Yeah, again, so I think talking to your insurance company and your local inspector is the best thing to do there. There's, like I said before, there are maximum refrigerant quantities, or I should say maximum allowable quantities of flammable liquids in buildings, whether it's a refrigerant or anything else. And, what that number is based on the size and then what kind of mitigation things you have, like sprinklers and fire suppression systems and things like that. So talking to those people will give you the guidance you need to figure out what to do there.
And again, if you're in a warehouse and you're storing this, there's a very good chance you're also storing brazing materials. So you have some volatile substance there. So
yeah, I'm seeing a couple questions here about flushing the system to go from one gas to the other, and some kind of similar questions. So I want to actually reiterate the very first question that was asked was you cannot put R454B into an existing R410A system. And there's really two reasons for that. One of them is just it won't work right. The thermal properties are similar, but they're not the same. So we talked about the TXV.
Yeah.
Also, if you have a fixed orifice, it's not going to be the right size anymore. The compressor is not going to deliver the capacity you expect. But much more important than that, if you put an A2L refrigerant into an A1 refrigerant system, which is what R410A is, you have changed the flammability classification of that system, which is something you are not allowed to do.
Yeah.
And to be extra clear, simply, maybe you've received one of our systems and you see where the leak sensor is and you go, I'll just put the leak sensor in this new one. That's fine, right? It's not.
Yeah.
Because we have carefully picked the sensitivity and the location of that sensor for that cabinet application. You cannot retrofit R410A to 454B or 32 to any A2L in the field.
Yeah, and that also plays into some of the sheet metal changes we mentioned about making sure that the refrigerant, should a leak incur, that it pools to a level that we can detect it and then enact mitigation. There's a question here about an outdoor RDS. Are we going to have those?
No. So outdoor systems can only leak to the outdoors, and no RDS is required in that case. So a package system is a bit of a hybrid in that everything's outdoors, obviously, right? But you still could see an RDS in a package system because the evaporator side of the system could potentially leak inside through the ductwork, right? So you'll see protection there, but not for the outdoor side.
So there's more here than we'll ever be able to address. But again, we have another one of these next month, one after that. Lots of materials out there. We'll take all these, find some commonalities, and maybe hopefully disperse that out to our customers via a data sheet coming soon. Do you have anything to add?
Yeah, just as a closing comment, really appreciate your time and curiosity about this today. Much more to come. Like Dan said, we're going to get, in futures of these, we'll get specifically into some of these sizing calculations and things like that and the details of our instructions. The thing I really want everybody to hear here is, like I said before, if you're doing best practices already, you're almost there. You know, really, this isn't that different. I do think there's two ditches to fall in, though, right? One is being too worried about this. You should not be too worried about this. Again, we've done a lot of the work around the RDS and leak mitigation, and as contractors and installers, you know how to handle equipment, and you've been handling flammable gases for a long time, right? You know how to do that. It's not something we should be overly concerned about. The other ditch, though, is thinking it's no big deal. It's not no big deal. It does require some healthy respect and some care. And so as long as we stay between those two things, we're going to be really successful. And the key to that is reading the manufacturer's instructions. You know, we joke around in the office, we call them knee pads because we think that's what people use them for. But it's time to read the knee pads. There's going to be more in there. You need to be familiar with that, and being familiar with your local code requirements, which again, if you look at that AHR website, you can go find those and see their status. So
Great.
I think we're set up for a lot of success, and I'm excited to go forward here. So.
Great. Well, I appreciate all the expertise. I thank everybody for joining in. Hopefully you learned something. We're going to take this and respond to some of the questions we didn't have time to get to. But I appreciate you joining us today. Look forward to the next one we're doing, and well, you know where to find us if you guys have any questions. So Dan Ayres, Product Manager for Embry, our Director of Engineering. Thanks a lot.
Thank you.